United Launch Alliance presents live Atlas V launch coverage from Space Launch Complex 41 at Cape Canaveral Air Force Station, Florida. On board Atlas today is SBIRS GEO-2, the second space-based infrared systems mission for the United States Air Force.
Range go for launch. Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
This is Atlas Mission Control at T-minus 4 minutes and holding. Our 40-minute launch window opens at 5:21 p.m. Eastern Daylight Time. The launch count entered a planned 25-minute hold approximately 9 minutes ago. This hold is designed to allow launch conductor Scott Barney and his team time to address any last-minute items. However, at this time, the team is not working any issues, and we remain on schedule for a 5:21 p.m. liftoff. Good afternoon, and welcome to Mission Control at the Atlas Spaceflight Operations Center in Cape Canaveral Air Force Station, Florida. I'm Matt Donovan, and I'll be your commentator for today's launch. Following liftoff, you'll be hearing the voice of Marty Malinowski providing launch vehicle ascent data. As I mentioned earlier, Atlas V is launching the second dedicated satellite in the space-based infrared system. SBIRS, one of the nation's highest priority space programs, is designed to provide global, persistent, and taskable infrared surveillance capabilities to meet 21st century demands in missile warning and defense, technical intelligence, and battle space awareness. The system architecture consists of legacy defense support program satellites, hosted SBIRS sensor payloads in highly elliptical orbit, and dedicated SBIRS geosynchronous Earth orbiting satellites. The satellite constellation is supported by ground infrastructure which receives, processes, and delivers the infrared information to key decision makers. Lockheed Martin is the prime contractor for the program, with Northrop Grumman serving as the payload integrator. The SBIRS team is led by the Infrared Space Systems Directorate at the U.S. Air Force Space and Missile Systems Center and operated by Air Force Space Command. Recently, the launch team received a final weather briefing and was told the weather is within the launch commit criteria for this afternoon's launch. The weather briefing provided the following information. The probability of violating launch constraints is at 30%. The ground winds are 15 knots out of the east-southeast. The upper level winds are favorable, and the temperature is 75 degrees Fahrenheit. So we are proceeding towards liftoff with a planned T0 of 5:21 p.m. Eastern Daylight Time. ULA is using the Atlas V 401 configuration to launch the SBIRS GEO-2 mission. This is the 37th Atlas V Evolved Expendable Launch Vehicle flight since the inaugural launch in August 2002, and the 619th Atlas program launch overall. The Atlas V is produced in Decatur, Alabama and Harlingen, Texas. It is comprised of a Common Core booster powered by the NPO Energomash RD-180 main engine and a Centaur upper stage powered by the Pratt & Whitney Rocketdyne RL-10A engine. The SBIRS satellite is encapsulated within a 4-meter diameter payload fairing that will protect it during ascent. On March 4th, the SBIRS GEO-2 satellite was encapsulated in the 4-meter diameter payload fairing. The encapsulated payload fairing was mated to the Atlas V rocket on March 7th. The Atlas V is prepared for launch at the Vertical Integration Facility, or VIF. The VIF is located approximately 1/3 of a mile south of the launch pad. The fully integrated Atlas V was rolled to the pad at Space Launch Complex 41 yesterday at approximately 10 a.m. Eastern Time. Trackmobiles are used to transport the Atlas V and its mobile launch platform to the launch pad, a trip that takes approximately 30 minutes to complete. The Atlas V rocket stands 188 feet tall, or about 19 stories, and weighs more than 700,000 pounds fully fueled. At liftoff, the RD-180 engine produces more than 860,000 pounds of thrust to begin the vehicle on its journey. For those watching the broadcast, you're looking at video taken yesterday at Space Launch Complex 41. The animation you'll see after liftoff is referred to as Satellite Toolkit, or STK. STK uses a flight to track the path of the launch vehicle beyond the range of ground-based cameras. While the team completes launch final preparations, let's take a closer look at today's flight.
The following profile details the important events of this mission using approximate times. The Atlas V rocket will launch the space-based infrared systems satellite for the United States Air Force.
This is Atlas Mission Control at T-minus 5, 4, 3, 2, 1. And the RD-180 engine roars to life and liftoff.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 81 seconds. At 91 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas V is burning propellant at a rate of 1,600 pounds per second, traveling at approximately 16,000 miles per hour, and located 62 miles in altitude and 146 miles downrange. Booster engine cutoff occurs approximately 4 minutes after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned approximately 4.5 minutes into the flight. Cutoff of the Centaur main engine follows an 11-minute burn. The mission now enters a nearly 9-minute coast phase. At just over 24 minutes into the flight, the Centaur main engine is started for a second and final burn. This burn will last nearly 4 minutes. Following the second Centaur main engine cutoff, the mission enters a final coast phase. This coast phase will last nearly 15 minutes. At 43 minutes 19 seconds, Centaur releases SBIRS for the United States Air Force.
Launch on time verified.
Roger.
Switch to ready position.
This is Atlas Mission Control at T-minus 4 minutes and holding. We remain in the planned 25-minute hold as preparations for the launch continue. Launch conductor Scott Barney will poll the launch team in a few moments for the final go to resume the launch countdown. 27 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Scott Barney performs the final polling of the team. T-minus 1 minute and counting.
Screen.
54. Stable at step 3. 25.
Status check.
Go Atlas.
Go Centaur.
Go SBIRS.
20. 15.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition 2, 1, 0. We have liftoff of the United Launch Alliance Atlas V rocket carrying the second space-based infrared systems mission for the United States Air Force.
RD-180 pump speeds are within parameters. Pitch yaw roll program has begun. Vehicle body rates look good.
You are hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
RD-180 continues to operate well. Pump speeds are good. Ejector pressures are within parameters. RD-180 continues to perform well. As PU has gone to closed loop control, minor mixed ratio request has been made. The roll program has been completed. Vehicle body rates look good. Range track shows the vehicle right down the middle of the corridor. Mach 1. Body rates continue to look very good. Bus and battery voltages are stable. Max Q, body rates continue to look very good. RD-180 performance looks good as it throttles down, right on schedule. Current altitude is 10 miles. Downrange distance is 6 miles. Current velocity is 2,037 miles per hour. Booster engines continuing to perform well as we accelerate at 2.1 Gs. Coming up on our Q alpha limited steering enable. And steering has been enabled and a minor roll bias change in attitude has been accomplished. Signatures look good. Booster engine performance continues to be nominal. RCS pyro valve has been fired. That system is now pressurizing to flight levels. Signatures look good. Currently accelerating at 3.1 Gs. And the booster is making a roll change for thermal conditioning reasons, and that roll has been completed. Booster continues to perform well. Current altitude is 42 miles, downrange distance 89 miles. Current velocity is 6,909 miles per hour. Coming up on the 5G throttle segment, currently accelerating at 4.8 Gs. And boost phase cooldown has begun. The Pogo Pyro vent has been fired, currently accelerating at 5 Gs. And throttle back to 4.6 Gs in preparation for BECO. Boost phase chill down is complete. And we have BECO. Engine shutdown looks good. We have retros and stage separation. We have fuel and LOX pre-start. GN2 purge firing and the RCS is underway. We have ignition and full thrust on the RL-10. Looking for the payload for jettison momentarily. And we have indication of jettison, and video confirms we have a good separation.
This is Atlas Mission
Centaur
Control
Keys.
at T plus 4 minutes 41 seconds. Marty Malinowski just confirmed payload fairing jettison and all systems continue to operate nominally. The mission is in the first of 2 Centaur engine burns. Our next event, Centaur main engine cutoff, will occur in about 10 minutes. As the name implies, SBIRS GEO-2 will be inserted into a geosynchronous orbit. SBIRS GEO-2 is identical to GEO-1, which was launched on United Launch Alliance Atlas V in May 2011. The space-based infrared system consolidates operational military and technical intelligence requirements into a single space program, resulting in unprecedented global, persistent infrared surveillance capabilities. The following video provides a brief overview of this critical capability.
Global persistent infrared surveillance continues to be a critical national security space mission. The Cold War focus on strategic ICBM systems has expanded to include short and mid-range ballistic missile threats. The Defense Support Program maintains the legacy Cold War monitoring to warn of ICBM missile launches against the U.S. The replacement program is the Space-Based Infrared System, or SBIRS, which has already provided 2 infrared sensor payloads in highly elliptical orbits, or HEO. The SBIRS program is also deploying multiple spacecraft into geosynchronous Earth orbit, or GEO. Each has 2 independent infrared sensors. One is a scanner dedicated to missile warning with full Earth monitoring. The other sensor is a taskable starer that can focus on selected regions. Each pair of sensors acts simultaneously and independently of each other, providing a robust, taskable infrared platform. SBIRS is the nation's next generation of space-based infrared surveillance. The program has already proven its value with successful HEO payloads on orbit. With deployment of the GEO spacecraft, SBIRS will be an unprecedented resource as the nation's global, taskable, and persistent infrared monitoring sentinel.
Voltages are good.